Something no one expected just unfolded in deep space. 3I/ATLAS, the interstellar traveler, has erupted with a glowing ion tail. And by pure coincidence, NASA's Europa Clipper was perfectly positioned to catch it. This unplanned encounter could deliver the first direct measurements from an interstellar comet's tail, a discovery that might change how we understand the universe itself. Let's dive right in. When scientists talk about cosmic coincidences, they rarely mean something this exact. Yet, against every odd, an interstellar traveler, 3I/ATLAS, has just positioned itself perfectly for a moment no one expected, and two spacecraft, NASA's Europa Clipper and ESA's Hera, happen to be in the right place, at the right time, to witness it. No one planned this. But somehow it's happening, a once-in-a-lifetime alignment that might let humanity touch the debris of another star. 3I/ATLAS is unlike any comet you've ever heard of. It's not from our solar system. It came from somewhere else beyond the reach of our sun. It's only the third confirmed interstellar object in human history, following Oumuamua and Borisov. As it approaches the sun, solar heat has awakened it. Gases are venting out, forming a luminous ion tail stretching millions of kilometers into space. And now that alien tail, made of particles from another star system, is drifting right across the flight path of two human probes. A cosmic coincidence? Or something that was bound to happen once we started reaching beyond our home system? Europa Clipper and Hera were never meant to meet this visitor. Clipper is on a long journey toward Jupiter's moon Europa, searching for signs of life beneath its icy crust. Hera is heading toward the Didymos-Dimorphos system to study the DEART impact site. Two completely different missions, two different agencies. Yet, through the delicate math of orbital mechanics, their paths now intersect the invisible wake of 3I/ATLAS. When mission analysts ran simulations, they were stunned. Between October 25th and November 6th, both spacecraft will pass directly through the downwind region of the comet's ion tail. They won't get close to the nucleus, it's millions of kilometers away, but they'll pass through its outer plasma field, the region where solar wind carries ionized particles from the comet across the solar system. That's not just a chance flyby. It's the first opportunity to directly sample interstellar material, something we've only observed through telescopes until now. To understand why scientists are so excited, we need to look at what 3I/ATLAS really represents. Every interstellar object carries chemical fingerprints of its birthplace, frozen clues about how other stars formed, what elements they contained, and how they evolved. So far, every interstellar visitor has passed by too quickly, too far away, for us to measure anything beyond light and color. If Europa Clipper manages to record the ion and magnetic properties of 3I/ATLAS's tail, it could become the first spacecraft in history to physically detect material that formed around another star. It's the difference between looking at a postcard and actually stepping onto the landscape. Let's simplify what's happening out there. As 3I/ATLAS moves closer to the sun, solar radiation heats its surface, releasing water vapor, carbon compounds, and metallic ions. These gases become ionized, electrically charged, and are swept backward by the solar wind, forming an ion tail that always points away from the sun. That tail interacts with the sun's magnetic field, creating turbulence, bending lines of force, and forming structures scientists can detect from millions of kilometers away. The composition and behavior of this plasma tell us how interstellar materials respond to stellar environments, giving us a rare look at how other planetary systems might behave. For the first time, Europa Clipper might be close enough to feel those effects, to measure the unseen magnetic pulse of something not born under our sun. This event didn't come out of nowhere. Researchers have been modeling the geometry of three I/ATLAS's tail using a simulation tool called Tail Catcher. It predicts how solar wind speed and direction carry ionized gas across space. Based on its calculations, Europa Clipper and Hera will pass about 8 million kilometers from the main axis of the tail, distant but well within the diffuse region where charged particles roam. That's why engineers are now reconfiguring instrument settings on the fly, optimizing plasma sensors, recalibrating the magnetometer, and scheduling targeted data captures. Because this opportunity won't repeat. The tail's position can shift with every solar flare or wind variation. If the window closes, the data is gone, and with it, a historic chance. Here's the distinction. Hera doesn't carry instruments capable of plasma or magnetic field detection. Its value in this event lies in its navigation data, confirming geometry and helping refine 3I/ATLAS's trajectory. But Europa Clipper is a different story. It's equipped with a magnetometer, plasma wave sensors, and particle analyzers originally built to study Jupiter's magnetosphere. These tools are sensitive enough to detect even faint traces of ionized gas. That means, if timing and orientation align, Clipper could record the first ever in situ data from the extended environment of an interstellar comet. It's like standing at the edge of a storm, not to watch lightning, but to measure the electricity in the air. Researchers have three main goals for this encounter: ion and plasma characteristics, measuring the density, energy, and distribution of particles. Magnetic field structure, identifying how the interstellar tail interacts with solar wind magnetic lines. Comparative analysis, determining whether interstellar comets behave differently from native solar system comets under similar conditions. Even a partial dataset could change our understanding of how interstellar materials evolve under stellar radiation, and that in turn feeds directly into the bigger question: how common is our kind of solar system in the galaxy? Of course, it's not guaranteed success. Europa Clipper wasn't designed for this. Its instruments are tuned for Europa's harsh magnetosphere, not the faint, diffuse plasma of a passing interstellar object. Distance is another challenge. 8 million kilometers might sound close, but in space it's like trying to taste a raindrop in a hurricane. Still, even if Clipper detects nothing, no particles, no field change, that result remains scientifically valuable. A null reading would refine sensitivity thresholds for future missions and confirm how far a spacecraft must be to detect measurable plasma. In science, even silence can be data. Perhaps the most remarkable part of this story isn't the comet itself. It's how quickly scientists reacted. Both NASA and ESA reconfigured flight plans in real time, repurposing missions worth billions of dollars to seize a fleeting scientific opportunity that no one predicted. It's proof that exploration isn't always about building new spacecraft. Sometimes it's about being ready to pivot when the universe surprises you. This adaptability, this willingness to improvise, might define the next era of space science. Because as detection systems improve, more interstellar visitors will be found. And when they are, missions like Europa Clipper will already be out there, waiting to catch them. The upcoming Comet Interceptor mission is designed with these lessons in mind. Scheduled for launch later this decade, it will remain in standby orbit, ready to intercept the next pristine comet or interstellar object that wanders into our system. But how that mission is built, what sensors it carries, and how it operates will depend on what Europa Clipper learns right now. Real data from 3A/ATLAS's tail even fragments, could refine everything from instrument calibration to mission timing for decades to come. This unplanned event, born of chance, could quietly redefine how humanity prepares for encounters with the unknown. When we discovered Oumuamua, we could only observe its light and argue about its shape. When Borisov came, we watched it dissolve, helplessly distant. Now, with 3I/ATLAS, we might actually reach out and touch the traces of another world, to feel its ions, to measure its magnetism, and to read its chemical DNA. It's not just about science, it's about perspective. For the first time, human technology might physically interact with something formed around another star. Material older than our sun, drifting for millions of years before crossing our path. And all of it, by accident. As we speak, Europa Clipper's instruments are being fine-tuned. Somewhere in the cold darkness between planets, it's gliding silently through a corridor of charged particles that may have traveled light years to meet it. Whether it detects a signal or not, this encounter will be remembered. Not as a planned triumph, but as a moment when curiosity met coincidence, and humanity reached a little further into the unknown. The data may be faint, the event may pass quietly, but the implications echo loudly through every lab, every telescope, every dreamer watching the stars tonight. Because this isn't just another mission update, it's the beginning of a new kind of discovery. One that proves the universe still has a few surprises left for those brave enough to keep looking. So here's the twist. This entire event was never supposed to happen. No plan, no coordination, no billion-dollar mission, just perfect timing between an interstellar wanderer and two human probes crossing paths by pure chance. Yet that accident could redefine how we explore the universe. If Europa Clipper detects even a whisper from 3I/ATLAS's tail, it means we've touched something born around another sun. And if it doesn't, that silence still speaks, proving we're ready for what's next. So what do you think? Coincidence or cosmic design? Drop your thoughts below. We read every comment, and if you want to keep uncovering stories that connect science, mystery, and destiny, hit subscribe, tap like, and join us here on Galactic Breaking News. Because out there, between the stars, the next discovery is already on its way.